Today I discuss about introduction to Lebesgue measures. So, very important topic. Media analysis. So, first I have to subscribe this channel. If you have not subscribed, and like this video, like, and share with your friends. Just introduction. There are a lot of important theorems related to this. But I just introduce the Lebesgue measures. Let's start. First, we know what is the outer measure. Outer measure. So, first defining. We'll take a set. Any set B is a proper subset, which is a subset of R, real set of real numbers. Now, we'll take a countable. We'll take a countable family of countable family of disjoint open intervals. Open intervals. Intervals. I L Li, where I is the index set. It belongs to I is the index set. It belongs to the set of natural numbers. Countable set of natural numbers is countable. So we'll take countable family of disjoint open intervals such that the union of all the union of Li, L is the length actually, length of the length I must be superset of A, means must over A. So, so if this happens, then the outer middle is the outer middle. Outer middle defined by defined by, it is denoted by in this way, n, up top there will be a star of E, the set E, outer measure, set E, M means measure, it will be infimum of all y, where such that y belongs to y is equal to actually summation of mod of length open intervals we have taken. So all the sum of all the open intervals length will be y, and the uh, whatever the number, the uniform value will be the outer measure. So there can be many sums depending on the collection which can cover the uh, union of li. I have already said length I just supersede b of the e. So there can be a lot of collections which must be countable and disjoint. So and there you will get the sum of all of those. There you can get many values of y. So uniform value, the minimum value of is called the outer measure of the set A, and it will be 0 if A is null. If A is the null set, then it will be 0. One thing is that since it is the outer measure is showing the distance, via length, so must be non-negative. Always outer measure will be non-negative. It can be 0, the length can be 0 or must be positive. So it can always non-negative. And more thing that for any singleton set, the outer measure will be actually 0. There will be a 0 length. And actually uh, uh, in measure theory, any singleton set can be covered by uh, any disjoint set, any open interval. Like if A is a singleton set, A, B I am taking, sorry, B. So I am taking B. So if B is a singleton set, I am taking point B. So it can be covered by a single interval. I am taking an interval I such a way that it is defined by in this way b minus epsilon b plus epsilon, whose distance is very poor. Epsilon is tending to 0. So if you take the length, yeah, by mod side it means its distance of I, so it will be just 2 epsilon, this point minus this point, this will be 2 epsilon, which is tending to 0. So the uniform value will be, or limit point will be is 0. So its measure will be, for a singleton set, the measure will be 0, outer measure. Now we discuss about the Lebesgue inner measure. Lebesgue inner measure is defined based on the Lebesgue outer measure. How? For any set, I am now taking A set for any set A, which is a proper subset of R, subset of R, sorry, subset of R, set of reals. So the inner measure is denoted by in this way here. Now button have star sign, and there will be A. So this is the Lebesgue inner measure denoted by in this way, equal to if A is covered by an interval in the reals. A is a proper subset of a interval, closed interval, AB, proper subset of a closed interval AB. Then we will take this will be B minus A minus outer measure of the set A complement. Outer measure of the set A complement. So A complement means the points which are not in the sets A. So this outer measure must be subtracted from the length of the interval B minus A, and then we will get inner measure. So it is also non-negative. It must be greater than equal to 0. And for a single set, for a null set, if we take a is null, then if A is null set, then the inner measure must be 0. Inner measure must be 0. And level, what is Lebesgue measurable sets? Lebesgue measurable sets actually, if any set will be called any set A, any set A subset of R is set measurable, Lebesgue measurable, if we find that the outer measure of A is equal to the inner measure, inner Lebesgue measure of A, then we will call that the set is Lebesgue measurable. and the common value. What will be the common value? It is denoted. The common value is denoted by when these are equal, and the common value is denoted by just simply a common value is denoted by simply by m. So there must be it equal to m. The common value is simply m. If the outer measure and inner measure is equal, then the common value is for the Lebesgue measure. Just simply Lebesgue measure. So, one more definition I have to say that for any set A, any set A, set A subset of R is called Lebesgue measurable. If for each set, if if for each set E, any set, for each set, every set you can imagine of the subset of R, we have the outer measure of E must be equal to outer measure of E must be equal to outer measure of E intersection E plus outer measure of E intersection E complement. If this happens for any set, we can find out if for other any set and for each set except the set which have to be set Lebesgue measurable. For every set E you can take from the set of figures. If this happens, then you can say that this set E is Lebesgue measurable. So we have to keep in mind there are many properties Lebesgue measurable. I will discuss later. Later. So I have just introduced you what is about outer measure, what is what is measurable sets. So I hope you like this video. If you like them, like, and if you have not subscribed this channel, then subscribe to get all these videos. Thanks for watching.